So today we're going to be solving section 1.3 that is included in your science week 5 periodic, including with section 1.1 and 1.2. Oh, wrong quiz, sorry. This one. So let's start. Water is made up of hydrogen and oxygen atoms combined in fixed ratios. What is true about water? So, three statements about water that are true. Now, water is a compound because here you have it in the question fixed ratios. Now, all water molecules are identical. Yes, because H2O is the molecule, right? So like you're not going to see a different molecule in water, right? It's going to stay H2O. Now, it isn't an element because like you can break it down into hydrogen and oxygen. And it can be broken down further, we said, so it's a pure substance. Why? Because compounds, just memorize this, okay? Compounds and elements are both pure substances because water is made of hydrogen and oxygen, right? Next, how do the properties of water compare to those of hydrogen and oxygen? Now, water here is liquid, but hydrogen and oxygen, they're gas, right? They're gases. So they are different. What are hydrogen and oxygen called? Hydrogen, oxygen are two different elements. They fall under that definition. Question 2 says, water is made up of hydrogen and oxygen atoms combined in fixed ratios. Which statements are true about water? Now, it is made up of molecules, obviously. What do you mean it's not a compound? We just said it is, right? And it's a pure substance. Now we have those two. It is a mixture or all molecules are identical. Now you might say that it's a mixture because it's made of hydrogen and oxygen, right? But hydrogen and oxygen are joined by chemical bonds. See? H2, let's say those two are hydrogen and this one's oxygen. Those things right here are called chemical bonds, okay? But a mixture, the definition of a mixture is that they're not joined by chemical bonds. So all molecules of water are identical. Now those two are just like a repetition of the previous questions. Water, hydrogen, oxygen, their properties are different. And hydrogen and oxygen are both elements. Question 3. Oh, okay. Complete the table by specifying whether each example is a compound, mixture, or element. Now an apple, for sure, like it's gonna be a mixture, right? Because it's two or more pure substances that make the apple. Like you can't say apple is an element or a compound. Like it just doesn't make sense. Now oxygen, we said, is an element. Sugar is a compound. Why? Because sugar is made up of three elements: carbon, hydrogen, oxygen, right? C6H12O6. So for sure it's going to be a compound. Maya used colored clay balls and straws to model different molecules. The red balls represent oxygen atoms and the blue balls represent hydrogen atoms. And the black balls represent carbon atoms. Oh my goodness. She modeled a water molecule by connecting two blue balls to one red ball, right? We said here, the red balls represent oxygen, right? Oxygen. And the blue balls represent hydrogen, right? Because water here is H2O. Next, now, the black, we said, represents carbon, right? And those two represent oxygen. Two oxygen, right? That's why it's called CO2. 2 oxygen, 1 carbon. Next, Maya used different colors for the different atoms because each atom has what properties? Let's see. We have oxygen, carbon, and hydrogen. Why do you think she used different color balls? Right? Because obviously each one has its own properties. Each one has its unique properties, right? Now, the bond represented by two straws is what then by represented by one straw? Obviously it's going to be stronger. Why? Because if you have two straws, it's going to be way harder to break than with one, right? Because it's more bonded, see? Two straws, and here's like only one. Question 5 says atoms are the building blocks of matter. Elements, compounds, and molecules are made up of atoms. A compound, let's see, a compound is gonna be fixed ratios. When you see fixed ratios or elements, it's a compound. Now, easy, cannot be broken down. This one is the easiest one, element, right? And now here, when you see chemical bonds, it's a molecule. Now, gold, okay? Gold itself in the periodic table is an element, right? But two atoms of hydrogen bonded together. Let's see, let's go back up. A group of two or more atoms joined by chemical bonds is a molecule. You can always just check back because you literally match the definitions, right? Next, a mixture is made up of two or more substances mixed but not chemically bonded. Okay, now, mud. When we talk about mud, you still see the different parts of it, right? So it's heterogeneous. Steel. Okay, steel. Can you see the different parts like iron and carbon? No, so it's homogeneous. Whipped cream. Like whipped cream, for sure, heterogeneous. Because you can like because like for example when you place whipped cream in like water or like any type of solvent it won't dissolve, right? You'll still see it like very clearly, so it's heterogeneous. Air, do you see nitrogen, oxygen, carbon, and other um like substances in the air? No, so air is homogeneous. Next, the amount of what that dissolves. Okay, dissolves. What dissolves? The solute, right? In a given amount of solvent. You dissolve a solute in a solvent. Is known as solubility. Now, a solution in which the maximum amount of solute is dissolved. So when you see maximum amount of solute, saturated. Okay? Now, the solubility of salt in water is greater than the solubility of salt in olive oil because salt is definitely way more soluble in water. You just need to know that. Okay, there are three types of mixtures: solution, suspension, colloid. Okay, now this is very important. Okay, now suspension, for suspension here, suspension, it has, oh boy, large particles, large particles that settle and they're called sediments. Oh my goodness, what did I just write? Here. Sediments. Here. Now colloids let me change it to red, is the exact opposite. Colloids is small particles, small, I'll just write small, and they do not settle, they don't settle, and that's it. Did you see? They're completely opposite. So, keep that in your mind, okay, for the question. Now, large particles, we said, are suspension, do not settle. Colloids, sediment, suspension. You can say here, S for sediment, S for suspensions. Now, heterogeneous mixtures. They both fall under heterogeneous, right? Because you can just see the different parts. Suspension, they settle, colloids, they don't, but you can still see the different parts. Now, two examples of colloids. Now, fog is a really good example because although fog doesn't settle to the bottom, here, although fog doesn't settle to the bottom, you can still see it in the sky. That's like random fog or something. Yeah, you can still see it in the air. And does fog settle onto the surface of the earth? No, right? Now, another example of a colloid that you should actually know, which is important, is milk. Okay? Now, water for sure is not a colloid, and mud, colloid? No. Mud is suspension, and oil is something else, like completely something else. Question 9. Okay, solid solution, metal solvent, alloy. Okay? Now, brass is made of copper and zinc. Zinc increases the hardness. Now, honestly, have you ever seen flexible metal? No way. Like, it just doesn't make sense, okay? Now, can we really, does it make sense to say in a sentence zinc increases the strong of copper? No, it increases the hardness. And able to rust? You can't, right? Because alloys are made to improve the metal, and the ability to rust is not very good, honestly. And flexibility isn't good. Now, here, wheel rims are made of aluminum and magnesium to make them strong, right? Now it all makes sense. Question 10. A solution in a liquid is a liquid mixture with one of its components uniformly distributed. Okay? So when you see uniformly distributed, that's homogeneous. What are the components of a solution? For sure, solutes and solvents. Now, the universal solvent, okay? What makes most solutes dissolve in it? Water, right? We say, imagine salt in water, imagine sand in water, imagine like sugar in water, right? We mostly just use water as a universal solvent. Now, atoms combine in different ways to make a wide variety of compounds, right? A water molecule is made of two hydrogen atoms bonded in one oxygen. Hydrogen peroxide is made of two hydrogen and two oxygen atoms. Now, the atoms that make up water. Let's see. Water. Now we're only focusing on the atoms. Okay? Hydrogen, oxygen. Here also hydrogen and oxygen. So the atoms are the same. Now the properties of the atoms. Okay? Here we're looking at the atoms again. Hydrogen is the same as hydrogen. They're going to have the same properties. And oxygen is the same as oxygen. The same properties again, right? But then, the properties of water. Now, do you think water and hydrogen peroxide have the same properties? For sure, You are gonna find a difference in them. So different. Okay, that's it, and good luck for your periodic.